Welcome to Function Transformations Part 2, Summarizing. The best way to use this video is to take notes while I'm teaching. If you haven't watched Part 1, please go back and watch Part 1. And every time we arrive at a you try, pause the video and attempt the problem. In this section, we'll be doing the following. And we're going to start with vertical shifts. So when we have a function, any parent function, and we add a constant after it or at the end, or could also be in front, it shifts the function up. So if our vertex is here, it shifts our vertex up. So again, if you are adding, it's going to shift it up. If you are subtracting a constant value, it's going to shift it down if you're subtracting. So if our vertex was here, it's going to shift it down however many points there. Continuing to talk about vertical, we're going to talk about vertical stretching and shrinking. Now, a vertical stretch is when you're pulling the function up and down. So it's going to end up getting more narrow. And a vertical shrink is when we're pushing the function down vertically. It's going to get wider. A vertical stretch happens when we multiply a number outside of the function and it's bigger than 1. So our black function here is our parent function, and it has been vertically pulled to end up giving us that orange function. Here we have 1/3 x squared, so this number is multiplying on the outside of the function, and it's between 0 and 1. And so what happens to our parent function here is it gets pushed vertically and it ends up becoming more wide. Reflecting over the x-axis is when we multiply a negative on the outside of the function. So our parent function of the quadratic normally is up, but when we have a negative out front, it sends the shape down. Horizontal shifting happens inside the function or to the x variable itself. Now these get a little tricky because they're opposite. So when we add a or a constant on the inside, it shifts it left. So we added 3 on the inside here. So here was our vertex. It shifted our vertex left 3. When we subtract on the inside, it shifts it right. So our vertex shifts to the right 3. Horizontal shrinking is, so now we're talking horizontally, we're pushing in when we shrink, and it's actually going to get more narrow. So a horizontal shrink looks exactly like a vertical stretch. And a horizontal stretch is a pushing out, so it's going to get wider. Let's take a look here. If we're multiplying a number on the inside, it's going to be horizontal. If that number is greater than 1, it's a horizontal shrink. So we've got a number multiplying inside. It's bigger than 1. So this function gets horizontally shrunk in to make it wider. Here we're multiplying the function on the inside, so it's horizontal. The number is less than 1. So it is a horizontal stretch. We're pulling this function out to make it wider. And our last transformation is a reflection over the y-axis. This is when we multiply a negative on the inside of the function or to the x itself. So here's our example. We've got our parent function normally faces in this direction, but when we multiply by a negative on the inside, it shifts it to face in this direction over that y-axis. So you can pause the screen here, take any notes you like, and we'll do a few examples together. So for each equation, we're going to name the parent function and then list the transformations. So when I look at the g of x, I see the x squared. So the parent function is g of x equals x squared, or maybe we would say instead the parent function is f of x, but it doesn't actually really matter. So the only thing that's happening different here is this minus 3. It's happening to the function, not to the x. So that means it's shifting down 3. All right, let's look at number 2. It's f of x. So the parent function, let's call it g of x, something different than the transformed function, is the absolute value of x. Now we've got 2 things going on here, so we'll have 2 transformations. We will start with the stretching and shrinking. We have a number multiplying the outside. That means it's going to be a vertical something. That number is bigger than 1. It's a vertical stretch. We have a plus 1 on the inside. When we're adding or subtracting on the inside, it's left or right. So because it's a plus, it's the opposite. It is left 1. And finally, we've got this function here. This is our exponential function. 3 to the x. We have a minus 2 happening just to the x, so that's going to move it right 2. You give these two a shot. Press play when you're ready to see the answer. And there we go. We'll do one more example together. Given the parent function and a description of the transformation, write the equation f of x. All right, these can tend to be a little trickier. So f of x is equal to, we're dealing with x squared here. We want to vertically shift it up and shift it to the right. So to shift it up, we know we're going to have a plus 3 on the outside. But to shift it to the right, it needs to be inside a minus 1. So the mistake that happens is this. This is incorrect because that minus 1 needs to be inside of that squared. So we'll try it again correctly. We want that squared to be on the outside. There we go, plus 3. That's the correct answer. We've got the absolute value function. We're going to flip it over the x-axis. That's a negative on the outside. And we're going to vertically shift it down. That's a minus 1 on the outside. So that's going to be f of x equals, we need a negative on the outside, absolute value of x, and a minus 1 on the outside. You try these two on your own and see how you did. That concludes function transformations, part 2.